Hey everybody, it is time to wrap up chapter 4. And I know it was a pretty strange sequence that we did as far as the section numbers. But yeah, last section we did was actually 4-2, and we're going to keep that going. Like we're going to build on that because 4-1 is also going to be about graphing parabolas, these quadratic functions. Now, the key thing to realize right off the bat here is that in 4-2, the section we just did, we were given these quadratic equations in standard form. But this is going to be, what do we do if what we are given is this thing called vertex form? So there's like another major type of form that you can be given a quadratic function in, and it'll pretty much result in you doing a different strategy. So here is what vertex form is. You have you have some a value out in front, and then you have a quantity of x minus something all squared. See, there's still a power of 2 because it is quadratic. And then you have this plus something. And I don't want to get ahead of myself officially here, but this right here would be like a pretty good example of a quadratic function that was in vertex form with some number and then x minus some number and then the squared and then plus some number. So any equation that you could pretty much make the case that it was written in this form, okay, it'd be in vertex form. Now, vertex form is even easier, in a way to work with than standard form, okay? Because it turns out that this number combined with this number in your equation is literally the coordinates of the vertex. So your vertex is h comma k. Whatever this is, comma, whatever that is, that's your vertex. And this number out in front, this a value, will pretty much be your vertical stretch factor. Don't worry too much about that, but that's what it is. And your parabola is going to be flipped upside down if this number out in front happens to be negative. Okay? Now, let's just kind of make this as simple as possible, and let's do a bunch of examples. And hopefully that'll be enough for you to kind of catch on how you can easily just take an equation that happens to be in this very special vertex form and you can make the graph. Okay, so here we go. When you notice this, okay, and you kind of match it up with this vertex form, you're going to notice that your h value is 3 and your k value is 2. Now that's a positive 3 because remember, this might be something I'm a broken record about a bunch of times, but in vertex form, this minus is built in to the form. So the fact that this is a minus right here, that it's minus h, and this over here is like a plus k, it's definitely noteworthy. So our h is 3. Oh, come on, man. Let's just, why does everything gotta be so complicated? So our h is positive 3, and our k is actually positive 2. So just by looking at this equation, we know our vertex is 3 comma 2. Okay? And that would be right there. If we were actually drawing these graphs, you'd put your vertex at 3 comma 2. Now, knowing what your vertex is, you automatically know that your axis of symmetry is x equals 3. I mean, if you know your vertex, you know your axis of symmetry. So, because your axis of symmetry just goes right through the vertex. Now, as far as a maximum or minimum value, okay, check this out. Back here I said that if your a value is negative, that means your parabola is flipped upside down, which pretty much means if your a value is positive, that means your parabola is right side up. Okay? So notice out here, our a value is 1/2. So our u is going to be right side up. It's going to be a regular U shape. Now, what some other points are, you might have to maybe, like what if we were to plug in 0? Okay? If you were to plug in 0 for x, let's see here. 0 minus 3 is negative 3. When you square that, you get positive 9. Positive 9 times 1/2 is like 4.5. Plus 2 is 6.5. 1, 2, 3, 4, 5. So if I plug in 0, I end up getting 6.5. So that means a point would be like 0 comma 6.5, which means, over here would be another point. But I'm not that concerned about that right now. Once again, as far as a minimum or maximum, you could have understood simply from this a value that your u is going to be right side up. And if your u is right side up, that means there is a min. Okay, there's like an absolute lowest point. And remember, this is always about your y-coordinate. So your absolute lowest point would be basically the y-coordinate of your vertex. So you would say a minimum value of 2. Okay, and again, if you ever find yourself actually needing to identify 2 other points or actually draw your parabola, same deal as last section. You can like plug in 0 or plug in whatever you want for x. Remember here, it's oftentimes super easy to just plug in like 0, and I plugged in 0 and I ended up getting 6.5. So that led to this right here, which then you could like reflect it to the other side of the u of the parabola. But again, that's all I'm really looking for. So vertex form is really, 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 really nice. Now domain and range, I'm going to kind of trim here, and I'm going to just say is optional. But for this parabola, our domain would be negative infinity to positive infinity. And our range would be from what? From 2 and up. So from 2 to infinity. Next example. All right. Believe it or not, this equation is in vertex form. Okay. You could think of this as, you could think of this as yeah, okay. So you could basically rewrite this if you wanted to make it look exactly like vertex form, with kind of the 1 actually written, you know what I mean? And this minus 0 actually written. But I don't know, hopefully looking at this pretty much proves it to you that this is actually in vertex form. So when you, when you think about like what is our h value and what is our k value, it looks like our h value is 0 and our k value is 4. So that means, or sorry, negative 4. So our k value is negative 4. And so that means our vertex is 0, comma, negative 4. Okay? And so I guess I could write that in here. It's 0, comma, negative 4. And once again, if you know your vertex, it's like you automatically know that your axis of symmetry is x equals whatever that x coordinate is. And then your minimum or maximum, once again, all you have to do, what the heck, I hate when that happens. Okay. Sorry about that, a little glitchiness. So remember, minimum or maximum, all you got to do is look at like whether your a value is positive or negative. Here, once again, it's positive, so that means our parabola is going to be right side up. So that means this vertex is going to represent a minimum again. And the actual minimum value, once again, we're pretty much focusing on the y coordinate. So a minimum value of negative 4. So that's how that works. And again, once again, our domain, I don't really care, you don't have to do that. But our domain would be, once again, negative infinity to infinity. And our range would be negative 4 to infinity. Okay. Now I want to kind of go off on a tangent here and describe this from a slightly different angle. So, I want to point something out that all of these parabolas represent an entire family of functions. Okay? All the parabolas. And this right here, as plain and as basic of a quadratic function as you can get, just y equals x squared, that is the most basic parabola you could have. And this graph has its vertex at 0, comma, 0. And every other quadratic equation, like this one, and this one, and this one, and all of them, you can compare them directly to this guy, which has a vertex at 0, 0. And, when you have this minus 3 right there, you can think of this as, oh, having a minus 3 right on the x would cause this parabola to shift to the right. And this number attached at the end causes this parabola to shift also up 2. So a parabola that actually sort of started like this, right here, boom, this parabola. When you throw in this minus 3, it would shift it to the right, and then this plus 2 shifts it up. Now, this 1/2 happens to stretch it vertically, and that's why, these points ended up like here or whatever. And likewise, this right here, this only had a shift down. So this minus 4 at the end shifted the parabola that would have started here. Like if it was just y equals x squared, it would have had its vertex here. And that sticking that minus 4 at the end shifts it down 4. And there was no shift right or left, you know. And then once again, we have all this, but if you wanted to actually sketch this, you could, well, guess what? We can't plug in 0 because that would get us our vertex. So let's say we were to like plug in 1. Okay? If you plug in 1 and you do 1 squared minus 4, you get negative 3. So that means a point would be 1 comma negative 3. All right? Anyway. So looking at this, you could look at this and approach it like so. You could say, well, I mean, this would be just like the graph of y equals x squared. You know, so these two equations are identical, except this one has this plus 5 in this bubble, right? So a parabola that otherwise would have just started at 0, 0 with your vertex, this plus 5 makes it shift to the left 5. All right? Or again, you could like literally look at this and go, all right, my h value, if I think of this as being in vertex form, which of course it is, my h value is actually negative 5, right? Minus 5. So my h value is actually negative 5. And my k value is technically plus 0. So my vertex here is negative 5 comma 0, which automatically makes my axis of symmetry x equals negative 5. And seeing as how my a value is technically positive 1, that means my parabola would again be right side up. And so that means I have a minimum. And again, here you always pick the y value. Here, in case you care, the domain would once again be negative infinity to infinity. And my range would be from 0 and up, so 0 to infinity. Now this one, all right? If you match this directly against vertex form, you would notice that we do have a negative 2 out in front, but it's technically x minus 0 squared plus 0. All right, so if you wanted to kind of like rewrite this and fill in all the other stuff, like you realize that h is 0 and k is 0. In other words, there was no left or right shift, or there was no up or down shift compared to just like, you know, y equals x squared. But now look, the reason this graph would be different from just like y equals x squared is it's got this negative 2 out in front. Before I talk about that, it looks like our vertex would be 0, 0, which means our axis of symmetry would just be x equals 0. Right? I mean, just like that. And this negative 2, okay, would vertically stretch it, you know? And not to mention the fact that it's a negative 2, which would flip the parabola upside down. This would graph as an upside down parabola. Don't believe me? Well, what if we were to like plug in, well, we can't plug in 0, can we? Because that was the vertex. So let's say we plug in 1. If we plug in 1, okay, we're going to end up with negative 2, because negative 2 times 1 squared is negative 2. And then you reflect that. There'd be a point on the other side. So you see, you'd have a parabola that was upside down. And that's all because of this negative a value way out in front. So that means we would actually have a maximum value, because an upside down parabola has an absolute highest point. So here we have a max of 0. Okay? Max of 0. That's the highest y value, right? Right there. Now the domain, once again, it would still be negative infinity to infinity, but this time our range, slightly different. Since it's going down forever, our range would be from negative infinity all the way up to 0. All right, now this one, okay? If you look at this, we have this negative out in front, which would make the parabola end up being upside down. And this minus 2 right here, which would, if that minus 2 wasn't there, we'd be at 0, 0. That minus 2 makes it shift to the right 2 notches. And I don't see anything at the end here. It's technically plus 0. So there is no shift up or down. Remember, technically, our h value is 2. X minus h squared, and then plus k. And so our k value is technically 0. So our vertex here is 2, 0 for this guy, which makes our axis of symmetry x equals whatever that is, 2. And it looks like this parabola would also be upside down, because our a value is technically negative 1. And as long as that a value is negative, that means your parabola is upside down, which means we have a max of 0. Okay? Our domain would be negative infinity to infinity, and our range would be from negative infinity to 0. All right, last example, I think. It looks like this one, compared to just y equals x squared, it looks like this plus 5 would have you actually shift to the left 5. Okay? Because our h value is technically negative 5. Because this would technically say x minus a negative 5 squared. And our k value is negative 3, so that's a shift down 3 as well. So our final vertex, our final h comma k, is negative 5 comma negative 3. All right? And so we automatically know our axis of symmetry is x equals negative 5. Right? X equals negative 5. And what do we have, a max or a min? What's our a value out in front? Well, it's 1. It's positive 1. So this parabola would be right side up, which means we would have a minimum of what? Of negative 3. And so our domain would once again be negative infinity to infinity. And our range would go as low as negative 3 and would go up to infinity.